Welcome to the chapter 14, Create Telemetry to Enable Seeing and Solving Problems. This chapter has to learn the importance to telemetry. To clarify this topic, we say that it is an automated communication process. It provides us remote monitoring of processes or equipment, the sending of alerts or alarms to a control center or being platforms on the internet so that operation is safe and efficient. There is one example where Etsy applied this process in the production environment. They achieved to quickly see any intended deployment side effects and set metrics graph for solving problems rapidly and continuous monitoring.
It's important to have development and operation engineers creating production telemetry because it is important to have sufficient telemetry for the application we build and operate. When a rocket is launched by NASA, for example, there are automated sensors reporting the status of its components, and the idea should be the same with software. But each member of our team will use telemetry in a variety of ways. Development to diagnose application problems, for example, and operation to diagnose problems in production. But there are different logging levels to support these various usage models, like debug level. It's about anything that happens in the program, usually using when troubleshooting. Info level is about actions that are user driven, like beginning credit card transaction. Warning level is about something that could become an error, like database taking more time than expected. Error level is about error conditions like an API called failure. And fatal level, it's about when we must terminate, like a network daemon can't bind a network socket. In this context, we should ensure that all significant application events generate login entries like system data access, faults, errors, failures, delays, etc. We must use telemetry in our favor because if there is the culture of blame, people would avoid documenting changes and displaying telemetry because the problem would be visible to everyone. But if the problem is visible and telemetry helps us achieve this purpose, we could speculate what is causing the problem and also what is necessary to solve it. And questions can help us during problem resolution, like what evidence do we have that problem is actually occurring, and also what changes could have contributed to the problem, and also what could confirm the link between the proposed causes and effects. It's important to have metrics that can be easily created, displayed, and analyzed because it will enable everyone to find and fix problems. And we do this by creating the infrastructure and libraries to create telemetry for any functionality that are built. And usually these metrics are displayed in dashboards for everyone in the value stream to see it. But the process of creating a metric should be as easy as creating a line of code. And based on this idea, EDSA created an open source metric library called StatsD that can generate timers and counters with one line of code by using different programming languages to render metric events into graphs and dashboards. This graphic in this slide shows the number of successful and failed logins per minute, and this was created with PHP with statsd function. And since most of production issues are caused by production changes, the gray line in this graph represents when the code was deployed. Once we have production telemetry as part of our daily work, it is time to radiate this information to the rest of the organization. And this is usually done by putting the production telemetry in the central areas where dev and ops work. And by doing this, we promote responsibility because there is nothing to hide from anyone. And this can be extended to internal and external customers in order to demonstrate we value transparency. LinkedIn, for example, although they had created a large volume of telemetry, it was hard to get access to the data and analyze it. Thus, they started a new project to turn their production telemetry to in-graphs. These in-graphs helped them to see exactly what they wanted to see, adding the ability to make calculations across multiple datasets, make comparisons, and define custom dashboards to better pick metrics they needed in a single page.
We're going to talk about find and fill any telemetry gaps. To achieve the purpose of that, we need to establish telemetry at all layers of the application and deployment pipelines. With this process running, we can handle the gaps. These gaps impede the ability to quickly detect and resolve incidents. Once the telemetry works in the system, we need to be able to see everything it has. It's necessary some metrics from specific levels like business level, application level, infrastructure level, client software level, deployment pipeline level to achieve that purpose. By detecting and correcting problems earlier, we can fix them while they are small and easy to fix, with fewer customers impacted. It should be our priority when we use telemetry.
We have two main goals using metrics application in business, which are making sure that telemetry is generated not only around application health, but also measure how far we have gotten in achieving our business goals. To illustrate on that, if a business is using telemetry metrics around all of the user events that would lead up to the business's success and reflect in revenue of that business, then we know what we need to be adjusted to meet the customer outcome desired. These metrics will vary based on business size. When the business metrics become a part of a customer acquisition funnel, it is likely that a customer will make a purchase from that business. Example, e-commerce site, they measure their events by user activity and what they search. That is very well described using Ed Blankenship, Senior Project Manager for Microsoft Visual Studio Team Service. When the metric is attenuable, we can make decisions to change our product based on experimentations and testing. Unlike unattainable metrics where we can only store its information but not display them. By ensuring that we are generating telemetry that allows us to determine if the infrastructure is a cause and the source of any problems, if any, would to occur. When making the infrastructure available, we can identify what systems and databases are being affected. In the past, manuals efforts such as IT and CMDB were used to create links between a service and a production of infrastructure. Tools such as Zookeeper, etcd, console, and other things are discovered when links are automatically registered within our service, which enables the service to register themselves, storing information other services to interact with. Development and operation work together when metrics create context for our infrastructure. Jody McCulley stated that it is better to measure both dev and ops real business consequences of downtime than measuring operation against the amount of downtime. It is a risk to make changes. Small and frequent production changes occur after we create our deployment pipeline. When we overlay all production activities on our graphs, we make changes visible. For example, when a service handles many inbound transaction, production changes can result in significant setting period. We need to understand how fast performance returns to normal and what steps are needed to improve in order to understand the quality of service. In this presentation, we learned the benefits of telemetry. Proven by Etsy and LinkedIn shows it's critical to see the problems as they happen, so then it's easier to identify the cause and solve that problem. Identifying the problems becomes easy when we have all the elements available, so we can fix it before something catastrophic or major does happen or occur. Thank you for listening.